Next thing now will be to start doing the rotary table work. Everything's set up on there, and I'll get the wooden faceplate to put on the rotary table, and we'll start getting set up from there. It's time to replace this here faceplate and put on a brand new one. I got a bunch of them made up here. These are some old ones I had to use from other projects. I got some new ones I made up here. I think since I have a small piece, I'm just going to use a small faceplate here. And I'll show how I get that fastened on there and how we get that lined up and how we use that to get things lined up for this kind of intricate machining, because I have different center holes here that I have to adjust to, and that means there has to be realigning the workpiece on here, and that's very difficult to do with metal faceplates, but with wood faceplates I can just move that anywhere I need and just put wood screws in, and it lends itself to a lot of variability of putting projects on a rotary table for any kind of machining on the fly like that. So the first thing I'm going to want to do is I want to get the two bolts, which that will go in here and here, and so I'll just put this on here like this roughly, and I'm just going from one side to the other. I've marked on both slots here, and I just make a little line here just to give myself a little reference here to down the center there, and now I'll drill to drop these here bolts down through about like that they can catch in here. There's square nuts they can catch in here to act as T-nuts. Okay, and I have the depth stop here now. How far I want it to go down. And I got my two holes here. I'll do the clearance holes for the heads first, counterbores first. Of course, that allows the heads to drop down in there I need to. The through hole. And that should take care of it. I'll drop down the side like that, and then we have the nut on the side here to act as a T-nut. Okay, and then finally the screws through. And if I have this measured out right, I should be able to slide in one side, drop the other side down, and slide that in, and tighten them up. So grab a hold of that in a little bit. Same thing here. And now it's tight. So I'll just also readjust that a little bit to make sure it's more even, but you see how that lines up now. And the square nuts on the other side there makes the T-nut. Okay, so now we'll take this over to what I'll do now is I'll take this plate off and I'll take this over to the mill, and I'll get the rotary table centered on my milling machine first, and then I'll drop this on, and then we'll work from there to get the center point and get all of our measurements and things with the workpiece itself, and that's coming next. Okay, so the first thing I do is I get the rotary table set up first on center. The rotary table is centered on the milling machine. I tighten the table down so it doesn't move, and now I put the rotary table blank on, the faceplate on, because that now becomes my work surface. So I want to make sure it's down nice and tight, and I got it lined up pretty much where I wanted it at. Okay, now I'm good there. Okay, so now everything's lined up on center of the spindle, and so now I'm going to make the first reference hole in the center of the rotary table. Okay, now with a 3/16 inch end mill in there, I'm going to use that to drill through initially here at high speed. And I got everything locked in position here on the quill, so I'm going to drop the whole headstock down on the Z-axis. Okay, now what that hole does for me is that gives me a reference that whenever I move my table, anywhere I move my table, I can put my 3/16 end mill back in there again, and I can drop it down and move my table until this seats itself back in there again, and then I tighten my table back up again, and then I have it back on center again, because I am going to be moving the table different directions for two different kind of cuts and everything, so I will need this to relocate back again. As you can see, that drops in there really nice and locates very nice in there like that. Now it's time to start locating the part itself. So now I use my center finder here. And I'll use that now to locate my part in position on the rotary table. The first one I want to make is I want to do this here profile first, right here, and my center for that is over here on this side here, and I have those dimensions drawn off here, and I also have the mark right here that we did the other day. We did these marks here for this rotary table centers. So what I'll do is I'll center this mark here now under there, and then screw that tight to here, and then do this profile down here. So what I'll do is just put that on there like this. Drop this down until it's just barely touching. I'll get my magnifying glass and I'll line that up, and then I'll just make a few marks here to get that nice and in position, and then I'll screw this down and get that down nice and tight. Okay, just double check that with the magnifying glass to make sure my mark looks good. So I know I'm good there now. I can take this up. Get out of my way right now. This out. And I can tighten the screws now. I think that's all it needs. It's good and tight. If that wasn't tight, then I can thread a 1/4-20 into here someplace, and then put a 1/4-20 shaft in there, and I can put a clamp on there if I needed to. That's what's nice about a wooden faceplate. I can thread anything I want into here now. Wood screws, machine screws, just by tapping into that. But that's solid enough with those two screws there. That's solid. Okay, so next we'll get the dimensions now for the radius from here, and then we'll do our cutting. We have the rotary table center centered off in this here divot right here. That's where we're at right now. And so all we have to do now is just move the x-axis in a direction so that we can get the outside of the cutter to meet the outside down here at around 0.755 inches. And then that will locate this radius. I have this here set to 0.755. I'll just make a mark on the table here on the wood, and now I bring my cutter down so that the outside of the cutter reaches into this here corner right here that we just made this mark at right here, and that will give us our radius that we need for this cutting at that there center of rotary table being here. What I'm going to do is I'm going to move my x-axis only. So that means I want to turn my rotary table in an x-axis direction when I go to move it. So this line here is now facing in that direction there, and I want to get the cutter and that reference line in line with each other on the x-axis. So I'll just eyeball it, what I'm going to do this way here. It's just a matter of moving the x-axis only. And now I can just drop the bit down, turn the rotary table. There, I'm getting close to my line now, right there. Pull it in, turn the rotary table, pull it in, turn the rotary table, pull it in, turn it right there. Right there, I'll lock my rotary table for one moment here, and I'll lock the x-axis. Now the table is locked in position. I'll bring my cutter up, and then it'll be turning this direction here. Now unlock the rotary table. Can you see that? Yeah. And then I'll be going in this direction here to do the profiling. Alright, let's give it a try here. Drop it down a few thou. Cut you off. Bring it back. Set my image here. There we go. I'll bring it down about 10 thou. Beautiful. And I'll just keep that going now. Drop it about there and continue on. I put a clamp on back here, and I put 2 screws in here. Again, a nice thing about a wooden faceplate, I can put screws anywhere I want. I put 2 screws in on an angle, got their heads tight against the side here, so that any kind of pressure put on here now will keep that from turning on me. I'll show how it works now. These screws make nice backups now to keep that from turning. They keep it nice and tight now and steady, the workpiece. That's why I like working with wooden faceplates like this. You can put screws anywhere you need to in order to fasten things to it without having to drill and tap like you would with metal. I switched over to a 2-flute end mill. Makes it work a whole lot better. We're cutting into the faceplate now, so we're right down the bottom. We should take the piece right off now. Now that we still have this in this position here, let's put a chamfering bit in here. I'll find some sort of a chamfering bit, and I will do some chamfering here now in this here corner while we have it in that position. And that's coming up next. The closest thing I have to a chamfering bit would be a center drill. So I moved my x-axis on the table again a little bit to accommodate for that. And I'll see what I can come up with here on this. Touch off for a little bit. I'll just move the x-axis about like that. Let's see if I can. No, I don't want to do that. Come this direction with it. Let's drop that down a little bit now. Touch off a little bit at a time. Come in, block the table. Let's see what we come up with there now. Bring it down a little bit now. Walk the z-axis. I'll bring the table over a little further now. Off the table. Bring the table over another 10 thou. Bring it down a little bit on the z-axis. Right there. Bring it down a little more yet. The z-axis. Starting to get a chamfer there now. So what I'll do now, I'll bring the table in a little farther now again. Off the table. Chamfer. to keep the backlash out. No pressure on the table with my fingers here. Okay. Okay, that's not bad. Enough that I can file that in there now. Alright, that'll work. Okay, the next thing now will be to set up to do the next rotary table work, which would be the next curve, which would be this curve right here now. We just finished this curve here. It'll be this curve here now. It's next. And I'll have to set my rotary table for that now. That's coming up next. And you see how these here screws here are nice for backups. I can just pull them out. I can also take this out too. Using that their method of using a center drill to do the chamfering, left a ridge in the center there before. I don't know if you've seen that before when I was machining that. So just a little bit of hand filing, took that ridge out. And now I'm just smoothing it out a little bit here now, just getting that all smoothed out for the first profile. Okay, the next one now will be the second profile, and that will be to cut this down through here now. And that will be got to set back up on the rotary table again. But that came out nice as far as getting that ridge out of there. So at least I know if I get a ridge in there, I can file that out and get that smooth enough to work. Alright, let's go back to the rotary table. I did not move anything on the y-axis, but only the x-axis. I can move the x-axis over now to get back in the center of that hole where I originally was, because I did not move the y-axis. I only need the one table movement now to take care of that. That's right there. Okay, I can lock the x-axis in place there now. Just give a double check here. Make sure everything looks good. And that looks good. Alright. Checking this workpiece against the CAD drawing. Again, this is actual size. But look how close that comes when I put the center of the screw hole there with the center of that. Look how close that comes there with the curve. So that means I'm very much in line with my dimensions on the drawing to have that radius come out like that, like it's supposed to. So I hope I can get the same thing on this one here now, radius. If I follow my dimensions here as close as I can, I should get close to that at least. Alrighty, that'll be this curve here next now to do. Okay, now of course all this is just aesthetics and things like that, just for practicing doing some accurate measurements and accurate machining. That's all this is for, just to play around like that. But just for some ideas here, if I was in a situation where I had to machine something to exact diagonals and radius and things, at least I have some practice at it. Now what I want to do is, looking at the procedure here, I have a radius that I'm going to be cutting here first, and I have my center of that radius being right here, which would be this hole right here. We have a divot out here. I have the dimensions here of where I want my end mill to stop on both here, different stop points. But I also need to, once I get that radius machined, then I need to lock my table and then drive my y-axis so I can cut this here in a straight line, and then drive it and then turn the rotary table again and get it back this way here. So in order to get these here different angles here off a reference 0, when I put this workpiece on here now, I'm going to be careful to make sure that my rotary table is set on 0 degrees. That way I have a reference to work off of when I go to get these angles here machined out. I'll be able to use my 0 degree reference on the rotary table itself to know how many degrees to turn it to get this in position on the y-axis straight across. Okay, so that's what I'm going to do now is set this piece up on here now. I have the center of the rotary table back in position again here with the center finder. Everything's back in position there. Now I need to get the workpiece on there, but like I said before I do that, I'm going to set the rotary table to 0 degrees now. Now that my rotary table is set to 0 degrees, I have one more thing I have to do. If I'm going to put the workpiece on here and have that reference at 0 degrees also, it has to be put on here so that it's square with the table movements. So what I need to do, I need to establish a line anywhere on this here faceplate here that I can use as a reference for straightness, parallelness with, in this case I'm going to go this direction here with the y-axis movement. So what I'm going to do is I'm going to set up some 1, 2, 3 blocks here, and I'm going to set up a square edge right here, and then I'll be able to reference off of that with a gauge, so I can put a mark here and a mark here, and then I'd have my straight line that's necessary to do all my measuring off of to keep everything, so when I put the part on there, it's now would be square with the table movements. Alright, that's coming up next.